All right, so quick review. We talked about ecological succession. I showed you a video of me in Costa Rica in front of a volcano, which did make me nervous, if you were wondering.
Was that a video from like a while ago?
4 years ago, maybe. And then we talked about how climate is long-term averages, and that the reason the Earth is so nice has a lot to do with our atmosphere, about how we have just the right amount of water, CO2, and methane in our atmosphere to make us nice and toasty, because the sunlight, short wavelength radiation, gets through the window of the atmosphere and of your car, right? And then gets converted by surfaces into heat, which is longer wavelength, which gets blocked and trapped very effectively by your car window, less effectively by the atmosphere, but just enough to hold enough heat so that we're nice and toasty. Whereas, for example, Venus, which has way more water vapor, is practically on fire, and Mars is pretty much freezing. They don't have any, very little atmosphere at all. Today, we're going to play Are You Smarter Than a Harvard Graduate one more time. This is a twofer. This is a two-question question. So grab a half sheet of paper. Feel free to split it with your neighbor. All right, so question one. It's hotter here than it is here and here, yeah? You know this. Pretty much 80-something all the time. Not that, right? Much colder here and here. This is us. Well, this is us, right? Why? That's question one. No, write it down. I hope you are learning that it's okay to be wrong. And understand that I'm picking questions that most people get wrong. It's not you. Right? These are questions most people don't know the answer to. So that question then leads into the question you're actually going to get to see the Harvard graduates try to answer, which is this. Why is it cold if you live not at the equator? Because at the equator, it's pretty much, just dry season and rainy season. But above or below the equator enough, and you're going to see it being cold in some months and warm in other months. In other words, what I'm asking is, what causes the seasons? Some of you are realizing right now that when you thought you were answering the first question, you were actually answering this question.
I think in like areas under the equator, the seasons are actually reversed.
You're absolutely right.
But that wouldn't affect the answer, would it?
I mean, it'll make more sense when you know the answer. I'm finally going to beat the Harvard graduates. All right, you ready?
Life for the very best education. Students in our classrooms are free to learn science. Many of these students will graduate from college with the same scientific misconceptions that they have done entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the cause for the seasons is a topic taught in every standard curriculum.
Okay, I think the season happens because as the Earth travels around the sun, it gets closer to the sun, which produces warmer weather and gets farther away, which produces colder weather, and then hence the season.
How poles at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun, and it gets when we get closer to the sun, it gets closer to get further away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing.
Now, having looked around at the answers, not everybody answered the same way, like on the other one where you all had almost exactly the same answer that they did. But there's a lot of variations of that answer. Like, for example, I saw several papers that said, not that the Earth's orbit is putting the Earth closer to the sun during the summer, but that in fact the equator, on the first one, you said the equator is closer to the sun than the poles. And that difference in distance is what's causing the equator to be hotter than the poles. No, not at all. We're so far from the sun that the few thousand miles difference that this makes, as far as, if you work the angles out, it's not going to produce any detectable change in heating. So let's look at that first question first, because that's the key. You have to understand the first question to understand the answer to this question. Why is it hotter at the equator than it is at the poles? What's going on there? You want to give it a shot?
It's the tilt of their.
See, and that's the thing. I feel like you guys kind of got that hammered into you in 6th grade or whenever. And so now you answer tilt to everything that's like seasonal or equator related. And what you're actually answering with that is the second question. It does have to do with the tilt. But this doesn't. The equator part has nothing to do with the tilt. Land?
There's less sunlight in those areas.
Why?
Because well, at the poles, that's like the middle of the Earth. Like behind that is where it's dark. So it's like at the boundary. So it's like.
I think you're close.
And then,
I think you sort of know what you're talking about here.
the same areas that the poles are more mountainous.
Doesn't have to do with mountains.
The equator is very closer to the sun.
It's nothing to do with distance. It has nothing to do with distance. I promise. I know it seems like it should. It doesn't.
So because the Earth spins like that, the poles are barely moving. They're not. Well, the shadow that's there is going to stay there most of the time.
Mhm.
So, and there's a wider range where it can hit in the front, but when the poles are they're very small compared to where the tail is. I don't know. I had something wrong.
Y'all sort of overlooking the biggest aspect of the Earth geometrically.
So it's not that it is the direct or the distance from the sun, but wouldn't it be the tilt because of the way it's facing the sun?
That's what she said, and
But
that
not like the,
that helps us answer. That helps us answer the seasons question, but not the differential heating of middle versus poles.
Like the sun spits the equator more directly.
What do you mean more directly?
Like the angle that it shines.
It has everything to do with the angle of sunlight. Let me show you a couple things. Can we agree that that is transferring a certain amount of energy via, certain wavelengths of light to that board? A certain amount of energy per square centimeter, let's call it, yeah? Wait. Now, are we looking at more or less energy per square centimeter now?
Where to go? Oh, there's
Less. It's the same amount of total energy, but it's spread out over more space, right? So less per square centimeter. Yeah? Angle matters, right? This is transmitting more energy per square centimeter than this is, even though it's the same total amount of light. Yeah? Now watch. What is it about the Earth that makes the poles get less energy per square kilometer than the equator?
Because it's a sphere.
It's round. It's a ball. It's a sphere. That's all. When you shine light on a ball, inherently, part of the ball is going to get the most direct, call it perpendicular, angle of heating, and get heated more than the other parts. Now, the Earth is spinning, you're right, but that just means day and night. Doesn't change which parts are getting the most direct sunlight. So that's why the equator is hotter than the poles, because the sun is hitting a sphere. And if the sun's rays are coming in like this, the middle part of the sphere is going to get more direct rays, more energy per square kilometer than the top and the bottom, and there's sort of a continuum there, right? Now, if you understand that, now think of me as the sun, as I light up your life. And this is the Earth. And my eyeballs are emitting light, yeah? What's going on right now? Is the equator getting the most direct sunlight? Not anymore. Who's getting the most direct sunlight right now? The northern hemisphere. In fact, if it's exactly like this, it's 23.5 degrees north latitude that is getting the most direct sunlight. We actually draw a line there and call it the Tropic of Cancer. So it's summer for us.
Jackson, Kate Waldo.
If this is the case, yeah? Now, let's wait 6 months. I stay in the same place because I'm the sun. Earth gets halfway through its orbit and winds up here. Now I'm heating, well, most of the ocean. Ooh. A lot of Australia, yeah? And what's it like in Ohio? This, right? Winter. Yeah. So 2 things going on here. The first, the question you answered first, is latitude effects. And then the second thing is the seasonal effects. But words only get us so far. We should probably draw a picture, huh? A picture kind of explaining all this. Because we want to see those lines, those imaginary lines on the globe. And then there's some climate zones we got to name. So don't draw yet. Let me, I'll show you several different versions, and then we'll pick one to draw. All right, so here's, pick, it's either spring or fall in this picture, right? The vernal or the autumnal equinox, when the day lengths are equal, that the sunlight is most direct exactly on the equator. Again, I don't draw this. Let's draw a different version so we get more concepts in here. But we got the equator at 0, and then we got 23.5 degrees north and south. Those are Cancer and Capricorn, right? The tropics of Cancer and Capricorn, which is why we call the zone in between them the tropical zone, right? Then we draw 2 more lines, 66.5 degrees north and south, the Arctic and the Antarctic Circle. Anybody know the word root there? Why we call them that? It's Greek. Arctos means bear, B-E-A-R. As in bears, no bears. You get it? Because there's bears up here. There's no bears down here. It's literally the dumbest thing ever, but that's why they named it that. So above and below the Arctic and Antarctic Circle, we've got the polar zones, and then in between is you and me, the temperate zones. But of course, that's only true twice a year. Every other time of year, it's some version of this, right? Where it's colder here and warmer here, or this, where it's warmer here and colder here. That's probably the one we should draw. A happy summertime.
Why did they name it the Tropic of Cancer?
Cancer means crab. Capricorn means goat. They're astrological signs from back when, well, I guess people still believe in that stuff, but yeah. So I think it had to do probably with what constellations were visible or, you know, something like that. You need more? I mean, look it up. I might be wrong.
So Cancer means crab.
Mhm.
So if someone has brain cancer, they have brain grab.
I mean, where's that? Said to have been applied to early tumors because the swollen veins around them resembled the limbs of a crab.
Crabs were applied to swollen feet.
They look like
Oh, okay. I've heard,
How did
I've
you get
heard
that out of
applied.
there? The word was applied to the disease because of the way it looked. Okay, so that is it. I'm not going to pile any more work on you.